Hello, this is Physics 2212 Lab 5. The purpose of this experiment was to explore the interaction between the falling magnet and the tube of aluminum foil produces. Then, using a computer model to model this interaction and compare the lab results and model output. A quick result preview of this experiment was that the magnet takes about 1.216 seconds to drop, and the computer model showed that it will take approximately 0.969 seconds to drop. Now, some of the key concepts that we use in this lab are Newton's second law, Newton's third law, Bohr-Schwarz law, and Faraday's law. Now, the experiment data consists are the following. Magnet mass was about 0.21 kilograms, length of 2.25 meters. Foil width is about 0.02 meters. Inner radius is about 0.014. Outer radius is about 0.034. And the mu for the magnet is about 1.55. This was from previous labs. And now on the right are the time that it took for the magnet to drop through the foil. We did 5 trials, and the average drop time ended up being about 1.216 seconds. Now, moving on to the computer model of the code, we first started initializing some conditions. Then we calculated magnetic flux. Then we added gravitational force on the magnet, computed change in flux over change in time, and calculated magnetic force on the magnet, and applied Newton's second law. Now here are the coding results of the lab. You can see how it falls. Now for the questions or interpretations. In the video, the red ring is counterclockwise, the red wing is clockwise, the blue is counterclockwise. And as the magnet go down the tube, counterclockwise current resists against the change in flux. Now, if the dynamics of the system will change when we flip the magnet around, it will still fall, but the flux will decrease in the opposite direction. And how does the total time in tube in real world compare to the computational model? It's less accurate. Computation system can be made more accurate with more accurate mu from lab 3. Now, what does the shape of the velocity versus time plot tell us about the force acting on the bar magnet? It tells us that inside the tube, net force equals 0. And some possible sources of error include inaccurate mu from previous lab and human error when performing the experiment. And the what ifs. What if the resistivity of the conductor were reduced as close as possible to 0? How would the dynamics of the falling magnet change? The current would increase, the magnet would take longer to travel through the pipe. And what if holes and slots were cut into the tube? How would this affect the ring currents in our model? Magnetic force and the induced current would decrease, magnet would drop faster. That's it. Thank you.